Good morning, children. In the last class, we discussed few important topics of laws of a motion about the Newton's first law, second law, third law, momentum, distance, displacement, velocity, acceleration, and about the examples of this. An activity which shows that action and reaction both act on different bodies. All this we have discussed. Please, children, what are the questions I am saying? Write in a classwork, and whatever the concept I am explaining, once you go through the textbook, if you have textbook, if not, on the screen you can see the textbook. Just you pause it and read complete textbook. Okay. Now, fourth lesson, shall we start today's revision? Refraction of a light at a plane surface. What is a refraction? Bending of a light ray when it enters from one medium to other medium. Why it bends? Due to change in a velocity. Due to a change in a velocity, when a light ray enters from one medium to other medium, slightly bend its path. That phenomena is known as refraction. You can see here a coin. You can see the coin, the light ray, how it is bending. And when enters from one medium to other medium, that air medium to the water medium, slightly bending its path or a direction is said to be a refraction. And if we draw the normal to that, when a light ray enters from one medium to other medium, that is a denser medium to the rarer medium to the denser medium, what happens, ma? Rarer medium to denser medium, what you are observing? Light ray is entering from air medium to the water medium. So it is bending towards the normal. It is bending towards the normal. See the figure 2a. See the figure 2a. Interface, where the point or a layer where the mediums are separated, such place is said to be interface. So here v1 and v2 are the speeds of a light. Speed of a light, and nn is the normal drawn to that. So what we are observing, a light ray is entering from one medium to the other medium, that is rarer medium to the denser medium. At the interface, it is bending, and it is bending towards the normal. When it is possible, when it bends towards the normal, when the light ray enters from rarer medium to denser medium. Now you see the 2b. Light is traveling from denser medium to the rarer medium, it bends away from the normal. It bends away from the normal. So here bends towards the normal and bends away from the normal. Here we can see the difference between 2a and 2b. One is rarer medium to denser medium. If light ray travels, it bends towards the normal, and denser to rarer, it bends away from the normal. What is the refractive index? This is a refractive index. Speed of a light in a vacuum by speed of a light in any medium is said to be a refractive index. It is also known as absolute refractive index, denoted with the letter n. N equals to c by v. What is the c? Speed of a light in vacuum. V means speed of a light in other medium is known as refractive index, or also known as absolute refractive index. Okay. Now, here refractive indices of some materials are given. In this, water refractive index is 1.33, ice 1.31, and turpentine oil is 1.47. Next, benzene is 1.5, and diamond, remember, refractive index of diamond most important, that is 2.42. 2.42. Relative refractive index. Relative refractive index is denoted with the letter N21, not 21 it is. When I asked the oral test, most of them they pronounced it as 21, not 21. It is a 21. It indicates that second medium with respect to the first medium. So what is the refractive index of second medium with respect to the first medium? Speed of a light in first medium by speed of a light in second medium, that is N21 equals to V1 by V2. What is V1 and V2? They are the speed of a light in first medium by speed of a light in second medium. That is V1 by V2 is equals to V1 by C, that is V2 by C. That equals to 1 by N1 by 1 by N2. So from this we can write that N21 is nothing but N2 by N1. This is known as relative refractive index. And a simple lab activity is given to obtain the relation between angle of incident and angle of refraction. What you have to do, you have to take a semicircular glass disc and place on the chart. Draw the outer edge of a semicircular disc with the help of pencil and draw the angles. See the figure, you can understand. See, draw the angles and place the semicircular disc on the horizontal line. Focus a light such that it is passing through that. You can observe slightly it enters into the other medium. So the angle which we are making is the angle of incident, and the ray which is coming out through the glass, semicircular glass disc, that is said to be a angle of refraction. Angle of refraction. So here find sin I by sin R for every I and R equation for every incident ray. Note, take the help of your teacher to find the values of sin I and sin R for each case. Finally, we will get the ratio is constant. What is meant by constant? As the I is increasing, R also increases. As I is increasing, R also increases. So this ratio is said to be a constant. Constant means don't think that it remains at particular place. When I is increasing in particular ratio, R also increases in the same ratio. Then both are said to be a constant. So here sin I by sin R, that is sin I means angle of incident, sin R means angle of refraction. Both are constant. And sign values is asking, ask the teacher, take the help of your teacher to get the sign values. Already once in a video I dictated all the sign values for sin 30, sin 45, sin 60, sin 90, sin 0 also. Okay. Next. Snell's law. What is the Snell's law? Sin I by sin R is equals to V1 by V2. What is the V1 by V2? Speed of a light in first medium with respect to the speed of a light in a second medium. Based on that we have a sense law. So, and next, critical angle. What is meant by critical angle? You will observe the certain angle of incident. The refracted ray does not come out but grazes the interface separating air and glass medium. Measure the angle of incident for that situation. That angle of incident is called critical angle. What is every time when we focus, see this is one red color light. So light ray is entering from denser medium to the rarer medium. So all the rays are not entering into the rarer medium, but one particular ray is grazing in the interface, and such angle of incident is known as critical angle. Per particular angle of incident, a refracted ray grazes the interface instead of entering into other medium. Such particular angle of incident is said to be critical angle. And what is the formula of critical angle, ma? Critical angle is nothing but 1 by sin C equals to N1 by N2. 1 by sin C equals to N1 by N2. What is N1 and N2? Refractive indices. Relative refractive index. Okay. So sin C equals to 1 by N12 means speed of refractive index of first medium with respect to the refractive index of second medium. Okay, children. Next, mirage. Already I explained you about the mirages, and before that let me talk about the diagram here. Take a tumbler and fill it with place a coin at the bottom of that and observe the coin. Move aside and move apart from that coin such that you are not able to see the coin. Now you ask your friend to fill with water. You can see the coin as a image on the top surface. Image on the top surface. So this is also one example for refraction. Here mirages. What are the mirages? During hot summer day, air just above the road surface is very hot, and air at altitudes. Altitudes are nothing but heights. is very cool. It means the temperature decreases with height. As a result, density of air increases. Temperature is decreasing means it occupied with the air. So density of the air increases with the height. We know that refractive index of air increases with density. Thus refractive index of air increases with height. So cooler air at the top has greater refractive index. Then the hotter air just above the road. Light travels faster through thinner hot air than through the denser cool air. When the light from a tall object such as a tree or from the sky passes through the medium just above the road, whose refractive indices decreases toward the ground, it suffers refraction and curves path because of total internal reflection. See children, and the road surface is very hot compared to the altitudes. When you go towards the height, temperature decreases. As the temperature decreases, density of air increases. As the density increases, refractive index also increases. So refractive index of hot air is less than the refractive index of a cool air. So when a light passes from the tall objects like a pole or from the tree, due to change in the refractive indices, it suffers as a curved surface on the path due to total internal reflection, and we may feel it is illusion water-like structure on the road, and that is said to be a mirages. In Telugu we will say it has a endamavalu. Only in summer we will get a chance to see the mirage on the roads. Okay, next. Applications of a total internal reflection. Application means use. How the total internal reflection is used in our day-to-day life. See, when the angle of incidence is greater than the critical angle, the light ray gets reflected in the denser medium at the interface. Light ray never enters the rarer medium. This phenomena is called total internal reflection. When the angle of incidence is greater than the critical angle, at that time the angle of incidence, that ray should enter into the other medium. But instead of entering into other medium, it reflects in the same medium. Such phenomena is known as total internal reflection, and mirage is also example of total internal reflection. What is a critical angle, amma? At a particular angle of incident, light ray grazes at the interface. Such angle of incident is known as critical angle. And what is total internal reflection? When angle of incident is greater than the critical angle, light ray, instead of going into the other medium, it reflects in the same medium, not reflects in the same medium. Such phenomena is known as total internal reflection. Okay, what are the examples of total internal reflection? Mirage is one example of total internal reflection. Brilliance of diamonds. Total internal reflection is the main reason for brilliance of diamonds. Critical angle of a diamond is very low, that is 24.4 degrees. So it is light ray enters a diamond, it is very likely to undergo total internal reflection, which makes a diamond shine. As its critical angle is very less, light ray does not enter into the other medium, it reflects in the same medium. Due to the twice or thrice reflection, diamond shines more. That's why brilliance of a diamond is more due to total internal reflection. Next, optical fiber. Total internal reflection is a basic principle behind working of optic fiber. An optical fiber signals through light pipes, for example, about 200 telephone signals approximately mixed with the light waves may be simultaneously transmitted through a typical optical fiber. The clarity of signals transmitted in this way is much better than the conventional methods. Okay. Now comes to the optical fiber use. Where it is used, optical fibers are used in signals and in telephones, signals, and it is used in hospitals also to get the internal image clear. Refraction through glass slab. Most important, take a glass slab, place on a paper and draw the outer edges of the glass slab with the help of a pencil and draw one on the particular line, draw one normal perpendicular line and fix 2 pins on that particular line. Place a glass slab and observe the image of the pins through glass slab. So point with the help of pencil where you are getting the image other side of the glass slab. Remove the glass slab and join the lines. So the distance between two parallel rays are said to be a lateral shift, and the distance between two perpendicular distance is set between two rays is said to be a vertical shift. So thickness of a glass slab also measured by using the formula. What is that formula? Thickness of a glass slab by thickness of a slab minus vertical shift. So the perpendicular distance between P and Q is said to be a vertical shift, and the parallel distance between them is said to be a lateral shift. So nothing is there in this. Take a glass slab, take white chart, fix on the table with the help of a clamps. Place glass slab in the middle of the paper. Draw the outer edges of the glass slab with the help of a pencil. Remove it, and on the longer side, that is AB or CD, name the vertices ABCD. On the longer side, whether it is a AB or CD, draw one perpendicular line, and on that perpendicular line make certain angle of incident. Fix 2 pins. After fixing 2 pins, place a glass slab and observe the image of that pins through the glass slab. So where you are getting the image, point that points with the help of a pencil. Remove the glass chart and join that. What you will observe, the parallel rays are formed, and that gives the distance between two parallel rays gives the lateral shift, and the perpendicular distance between P and Q gives the vertical shift. And what is the formula of a refractive index? Thickness of the glass slab minus thickness of glass slab minus vertical shift. So what are the topics should be covered in this lesson? That is refraction. What is a refraction? Bending of a light ray when enters from one medium to other medium. Why it bends? Due to change in a velocity. Due to change in its speed, speed of a light, the light ray bends its path. And next, it bends towards the normal and bends away from the normal. Light ray bends towards the normal and light ray bends away from the normal. Away from the normal. When it bends towards the normal, when it travels from rarer to denser. Denser to rarer, away from the normal. What is relative refractive index or absolute refractive index? Speed of a light in vacuum by speed of light in other medium. What is the relative refractive index? Speed of a light in vacuum by the speed of light in other medium is said to be a relative refractive index. And we discussed about critical angle. What is meant by Snell's law? Sin I by sin I is equals to V1 by V2. And what are mirages? Generally on the roadside, temperature is very hot compared to the altitudes, that is the heights. As we move towards the height, temperature, atmosphere is very cool, it shows temperature decreases. When temperature decreases, density of air increases. As the density of air increases, relative refractive index also increases. So due to change in the refractive index, when a light ray passes from a tall surface or from the pole, it takes a curved path due to total internal reflection, and this is said to be a mirages. We feel water-like structure on the road, and this process is known as a mirages. And next, what is total internal reflection? When angle of incident is greater than the critical angle, at the time light ray, instead of entering into the other medium, it reflects in the same medium. Such phenomena is known as total internal reflection. And what is the critical angle? At particular angle of incident, light ray grazes at the interface, and such angle of incident is said to be a critical angle. And And how you will find the refractive index of a glass slab? Simple activity is given. Take a table, fix a white paper on that with the help of a clamps. Place a glass slab, draw the vertices with the help of a pencil. Remove it, name it as ABCD. Draw one perpendicular line on the longer side and fix two pins at particular angle of incident. Now you place glass slab and observe the image of that pins through glass slab. What you will observe? You will get a image on the other side of a glass slab. Remove the glass slab, join that points with respect to the normal. And the distance between two parallel rays is said to be a lateral shift. Perpendicular distance between 2 points P and Q is said to be a vertical shift. And how we will find the refractive index? Thickness of a glass slab by thickness of a glass slab minus vertical shift. So read well. Few answers let me give about this. Fifth answer, explain the formation of mirage. Next, why do stars appears with twinkling? Sixth, explain the refraction of light through glass slab with a neat diagram. Fifth, sixth, seventh. Fifth, sixth, seventh. Next, why does a diamond shine more than the glass piece cut the same shape? Application of concept, fourth one. Next, higher order thinking. Why it is difficult to shoot a fish swimming in water? Next, when we sit at campfire, objects behind the fire are seen saving. Give reason. So, first reflection of a concept, that is 3 answers I gave. Fifth, sixth, seventh. Next, application of a concept, I gave the fourth answer. Higher order thinking, first time, third. These answers you have to write one time in your classroom. Thank you, children.